Problem number 12, and this problem is actually from the study guide that I made copies of and passed out during the day you guys took the quest last Thursday and Friday. So this comes from that study guide, and I'm not sure if you can find this anymore if you don't still have it, but anyway, I was asked to give an explanation for this problem. Problem number 12 is asking you to evaluate this this expression here, and this is called the difference quotient. This takes us way back to September of last year. Evaluate the difference quotient here, f of x plus h minus f of x all over h, for the function f of x is equal to 6. So there's a few different ways to approach this, and I'll try to help you with a few different ways to think about this problem. F of x is equal to 6, which means that the value of the function remains constant despite what the input is. In other words, no matter what x you plug in, you're going to get 6 out. You plug in a 1, you get 6. You plug in a 5, you get 6. You plug in 0, negative. No matter what you plug in, you get 6. In other words, if you plug in x plus h, so if this is your first video that you've seen, you realize that I'm having trouble writing really neatly with my mouse, and so bear with me here. That's the best we're going to be able to do right now. So f of x plus h is also 6, and so all we have to do is to evaluate this expression, you evaluate f of x plus h, which let's get a different color here. We know that that's 6, and we also, again, we're told that f of x is also 6. So what we end up getting is 6 when we substitute in for the f of x plus h and the f of x. We get 6 minus 6 divided by h, and so we get 0 divided by h. Now, h is just this random constant, and so we just get 0. So that's the one way to do this is just basically the way we do this all the time. We just replace our expressions in the numerator with what the values are, and then we simplify, and then simplify as much as we can get. We end up getting 0. Okay, the other way to look at this is, since f of x is a constant, this difference quotient, which represents the slope of any line segment through any 2 points on the function, okay, and that's a deeper level of understanding, yet that's the understanding that allows you to just say, oh, that's a constant, so the difference quotient is going to have a value of 0, because this represents the slope between any 2 points. And let me show this to you visually, and you might have already, if you're still with me, I appreciate it. That does say slope. And so, again, if we look at the graph of this function, we have our x and y axes, and what color should we use here? Let's use this color. F of x equals 6. Okay, and so if we draw the graph, we're going to draw 2 points on that function. Let's see, let's use this color here. We have a point right here and a point right here, and the difference quotient is basically the slope of the line through those 2 points, and the slope of the line is 0. M equals 0. Okay, slope of 0. So no matter how you slice it, you get 0.